we're going to go into our next talk. This is actually super exciting. We have two guests coming on for our next talk, which I think is the most coolest thing in the entire world. Quickly, let me go. 1 second. Oh yes, we have McKenna Sandra, who's an AI research assistant, and presenting with her is Colin Zamansi, who is also an undergraduate research assistant. So we have an amazing crew coming on to talk about data collection for human action recognition. So take it away. We're super excited to hear what you have to say.
Hello. Hi.
Sandra, I think I'm hearing a little bit of fuzziness in your mic.
Yes, I can hear that too, but it looks like Sandra is even muted. So I'm wondering where it's coming from. You are muted currently. Sandra, can you say hi?
Hi. Can you hear me? Okay.
It might be coming from Colin.
Okay.
AI is all around us. It's powering our lives in ways we never thought possible. With Microsoft AI, leveraging the power of AI and ML in your projects has never been easier.
It was easy for us to go from simple proof of concept to actually productionizing it and deploying it at scale.
You don't have to be an expert in data science to leverage machine learning and artificial intelligence capabilities.
You could build your entire machine learning models using the machine learning tools, scale up your development, and push it over to Azure.
AI is waiting to make your ideas into realities. From intelligent baby monitors and AI detecting bacteria in our water supply, to algorithms trained to detect people in disaster zones, and OCR unlocking a whole world of intelligent image classification and search, the only limit to what's possible is your creativity and imagination.
It's a really powerful tool set. Some of these algorithms can see things in images that humans can't.
What we see now is running AI models on edge devices where you're not in, a cloud data center or not on premises with large servers is actually reality today.
With Microsoft AI Lab and AI School, you can discover the latest and greatest in AI projects and get access to architecture diagrams, source code, and step-by-step guides for getting started with AI tools.
With advancement of deep learning neural network, now you can empower yourself to find your own use case and how you want to change the world.
What will you build?
Awesome. Welcome back to the Global AI Student Conference. Welcome to our two new guests who are here to talk about data collection for human action recognition. Feel free to take it away whenever you're ready.
Okay, hi guys. So we will be talking to you about this project we're doing. Human activity recognition, monitoring the recovery of orthopedic patients. So my name is Collins Emasi. I am an undergraduate student and also a research assistant at the Center for Data Science and Artificial Intelligence. And this project I've been working with my colleague, and I'll let her introduce myself, and then I'll take you guys through the first half of the talk, and then she'll proceed from there. So McKenna, over to you.
Hi everyone. I hope you are as excited as I am to be here. So my name is Sandra McKenna. I'm an engineering student. Collins is my classmate and also my project partner. And I'm also a Microsoft Learn Student Ambassador. And I'm super, super excited to be here sharing this project with you guys.
Okay, great. So what is human activity recognition and how can we use it to monitor recovery of patients, and who are these orthopedic patients? So first things first, orthopedic patients, there are patients who are diagnosed or have like a condition of skeletal deformity, who so these patients are treated for those conditions. And maybe if we can take an example, if someone was involved in an accident, so maybe they are recovering. So we want to use this technology in order to like monitor how they are recovering, how are they recovering, at what rate. And human activity recognition is a type of classification machine learning task whereby you take time series data, and from there on you try to predict what the person in the images is doing. A video, for example, is a time series data where the frames of the images are like sequential. So yeah, you take that data and then you try to predict what type of activity the person in the video is doing. So with this technology and with this task, we want to like apply this technology to try to solve this issue. And with that, I believe we can be able to monitor patients, their recovering, how, yeah. So in this talk, we will introduce DCell to you, the center that we both intern at. And then from there, we'll introduce the project that we are doing. We'll talk about the timeline, how we've been doing things from since we started up to now, where we are. And then we'll talk about the data collection process, why first of all we decided to collect our own data, because I know there's already existing data from the University of California that is applied to this particular task. Then we'll visualize some of the data that we collected. We'll talk about the model and the inference of the data. And then we'll share some thoughts about where we see the project going in the future. And then from there, with many, many thanks, we will conclude. And yeah, I believe all of us will have learned a thing or two. So about DCell. So DCell, like we've said before, it's the Center for Data Science and Artificial Intelligence. Both me and McKenna joined the center last year. From there on, we've been doing different projects, and this is one of the projects that we've been doing. Yeah, DCell is focused on solving, from the slogan you can see, we are focused on solving real world problems, and this is to mean problems that you might encounter on like a daily, on a day-to-day basis, right? So for example, like this task that we're doing, we like, these are challenges that you might encounter out there. So from the vision you can see, we aim at being a leading to lead in data science and artificial intelligence center, and excel in research and problem solving. So that's in a nutshell what DCell is. And now to the project, the human activity recognition. First of all, the World Health Organization defines health as a state of complete physical, mental, and social well-being, and not merely just absence of disease or infirmity. So with this knowledge, we see that physical well-being is a key part in health, right? So if you can monitor how a patient is doing physically, then we can gauge how we can get an insight to how healthy the patient is. So what we can assume is if a patient is not walking without some level of difficulty, or cannot sit down without some level of pain, and cannot stand even with just being uncomfortable. Okay, I think standing has an issue there, but standing without not how a healthy person might stand, if that brings some sort of clarification. But yeah, if these things are not met, then we can assume that the patient is not at a complete health state. And now, if we can be able to monitor this, like how long a patient is walking, how long do they stand, if they walk, how far do they walk, if they are lying down, for what period of time do they lie down, for how many hours do they sit, things like that. If we can be able to monitor these things for a period of time, then we can be able to tell how well the patient is recovering. So, but how can we measure these things? How can we keep track of them? This is now where the artificial health assistant comes in, right? We had an idea of coming up with an artificial health assistant that can be able to do this task, right? The artificial health assistant can be able to track and record the daily activities of a recovering patient. It can as well analyze behaviors based on the data that we collected, and can inform the caregiver or doctor of the patient's status and patterns, what do they do on a daily basis and stuff like that. And it can also remind the patient on when to do some physical activities when the device notices that the patient has been maybe sitting down for quite some time, lying down for quite some time. Yeah, just remind the patient on doing some physical activities, because that is a pathway to now recovering, going to recovery. So the timeline of our project. We started this project last year, around September, when we were all at home. We had a lot of time to think, and this idea came to us. We thought of how to, these patients, how can we monitor them? Because in a traditional sense, patients are usually just sent home, told to do this and do that, but the doctor cannot really keep tabs of what the patient is doing. And also the patient themselves, sometimes they may just maybe forget or find it hard to do some physical activities. Yeah, so we came up with a concept. We did some research on existing projects of the same. There was the data from the UCI data, that's the University of California. They produced a data set that can be used in this particular project, but we had some conflict with it, and my colleague McKenna will be talking at a more deeper level of the data collection process. And then we'll be at around November, after we had completed the formulation of concept and research, we started building a data pipeline system. We wrote some code, built an app. We were at home by then, so we were just collecting data, sending it to some database somewhere, and then from there on, we at around December, these things are taking, I guess, exactly 1 month. So around December, we started the data collection process. We were, at that time, me and McKenna, we were the only people doing the data collection. So it took us quite some time to have big enough I can't say big enough because the model, McKenna will talk about that, but yeah, some data to start some machine learning techniques. And then this year, at around February, we started the data analysis, building a model and seeing how well the data perform, how the model performs on the data. Yeah, so my colleague McKenna will now start talking about the data pipeline, collection of data and analysis of data at a more in-depth level. And from there on, we'll see how we did on how the model did on the data. And yeah, so McKenna, over to you.
Thank you, Colin. Just to pick up from right there, like he mentioned, we decided we'd collect our own data, and I'm sure any data scientist or machine learning engineer knows that data collection is no walk in the park. So we took on this task and decided we were going to collect our own data. So what we were using to collect the data was a sensor called MetaMotion R sensor. So what you're seeing right now is actually images of the sensor. So what we did is that we decided we would mount the sensor on a wristwatch and then put it on our left wrist. So the MetaMotion R sensors were donated to us by the CEO of the MDX lab. Her name is Laura, and we thank her for enabling us to have the sensors that we were able to use to collect the data. So yeah, like you can see that is how we were able to put on the sensor. So what would happen essentially is that you put the sensor on your wrist. We had come up with a program, or we had built a program that allows you to collect the data. So we had to build this program from scratch. And what you do is you open the program, you specify the activity you want to do. For example, we were collecting data for 4 activities. That is sitting, standing, lying down, and walking. So for example, I put the sensor on my wrist, then specify which activity I want to do, for example, walking, then also specify the amount of time I want to do that. So in our case, our default amount of time was 60 seconds. So every example for our data set was 60 seconds. That's one example. So after you've specified the activity and the amount of time, the sensor will begin to collect the data. And MetaMotion R sensor has a variety of sensors inside. So it's a small device that has very many sensors inside, but we are only utilizing 2 sensors. That's the accelerometer and the gyroscope. If you're not familiar with these sensors, I'll explain a little bit about them in just a few. But to continue on, so like I said, we have the program that's opened up. You specify what activity you want to do. For example, I want to do a bit of walking. If I say I want to do it for 60 seconds, and the sensor begins recording the data. After 60 seconds are over, what happens is that it will automatically upload the data collected from the sensor into our storage. So in our case, all the data was written into a CSV file, and from the CSV file, it was uploaded into Azure Blob Storage. So that's where we are storing our data. And from there, we'll then be able to query the data, or if you want to now use it in our model, we're getting the data now from Azure Blob Storage. So that's just a brief of what exactly we were doing or were getting at. So I'd like also to show you a bit about what the data looks like. But before I move on, I'd like to say what we're now, as we are collecting data, we're able to collect around 100 examples for each activity. So I said one example is 60 seconds. So, and we're doing four activities. So that's around 400 examples. So if you want to know for how long it took us to collect the data, it would be 400 times 60 seconds, or let's say approximately 100 minutes to collect the data that we had. And sometimes as you're collecting data, there are some mistakes you will make and you'll have to redo. Yeah, so it was quite interesting. The process of collecting data was quite interesting. So also, we were able to visualize and process our data, and I will be showing you in a few how our data looks like in terms of plot. And we were also able to train our model using the data that we had collected. And just recently, we were able to open source our project. So that means open sourcing our project allowed us to open us up to the world. So as you're listening to this and feel like I'd really love to be a part of this, or you'd really love to help us in collecting data or improving our program, or you'd like to use, you'd like to probably help us in training our model, feel free to check out our repo on GitHub and see what we're doing there and make suggestions, use it, play around with it, and give us feedback. Would really appreciate. But just as I said, I'd like to show you guys a bit of our data and how it looks like. So some visualization. So in data science, or when you're doing an AI project, it's very, very important to visualize your data. You need to know how your data looks like. If you need to understand the kind of data you're collecting or the kind of data you're dealing with. So visualization is very key in helping you try to make sense of that data. And as we are collecting at the beginning, we needed to see what kind of data we're collecting. Does it make any sense? Because we do not want to fall into the pitfall of collecting a lot of data that in the end we'll not be able to use because we cannot make any sense of it, or maybe there are anomalies along the way that would not allow us to use the data. So we kept on visualizing our data as we were collecting it, and we still do as we collect data to ensure that our data makes sense or it's data that we can be able to use. So what you're seeing right now is a plot of walking. So this is data from the accelerometer. So I said I talk about the accelerometer, and the gyroscope is what we're using. So what an accelerometer does, it measures the acceleration. Acceleration is rate of displacement. So it measures acceleration along the X, Y, Z axis. So that's what you're seeing here. And with now walking, it will look very different from something like sitting, or something like lying down, or something like standing. And if you put all of them, how they kind of look like, if you look at sitting, standing, and lying down, at first glance you might think they look the same, but if you look closely, you see that the orientation is a bit different, and also the values of each of the axes is very different. So as we're visualizing our data, we're like, yeah, we can see a very big difference between walking and the other activities, or sitting and standing. And the fact that you could see the differences made it at least much better for us to be able to feel that we are moving in the right direction, and enabled us to collect more data. So we did, after we had collected a bit of data and we felt we had enough to at least try building and testing it on our model, we built we fed our data into a neural network that had a few dense layers and an LSTM. So we're usually using the LSTM to train our data. We're using TensorFlow framework in this case to be able to build our model. So using TensorFlow and Keras obviously made it so much easier for us to be able to build the model easily. But as you can see, when we did evaluate our model and looked at the accuracy and the loss, we were not getting very good accuracies in as far as our validation set was concerned. And we thought that could be as a result of not having enough data. So we decided to go decided to take a step back and use simpler classifiers, because sometimes we want to use really big, like you want to use a neural network because neural networks are super cool, and you want to use a bit of deep learning because everyone is talking about it and it's the new buzz in data science and AI. So yes, we did want to use neural networks. But with the help of our director, we decided to take a bit of a step back and use a simple classifiers that you can find libraries such as scikit-learn. So we went for the logistic regression and the decision tree. And with that, we got much better accuracy. That's around 90%. To be very specific, our accuracies were around 95% for the training data and around 97% for the test data, which was way better than the neural network. That's the one thing we learned, that when you want to train your data, it's best to start from simple and then go into the more complex stuff like now neural networks, where there's a lot happening in between that you may not understand. But with simple classifiers, you can understand what's happening. You can test a few things here and there, and you can, from there, we'll now be able to now feed our data into the neural network soon enough. So, like I said, you can find our work on our GitHub repo. So I will not go so much into it, but this is just the beginning. Like, we have a vision, or our aim is to build a health assistant, and what we would want in the next coming months is to be able to collect more data, because we all know in data science, in when you're carrying out AI or machine learning projects, data is basically everything. It drives all the learning the system will do. So we'd like to collect more data to be able to effectively train our model, and we can be able to do better classification and eventually deploy our model on a device and having actual users use it. And now having the health assistant helping now patients, orthopedic patients. And this project would not have been possible without the help of our partners. We have that supported the program that we're a part of, MBET Lab, which who donated the sensors. That's the CEO, she donated the sensors to us. And we have our director from DPL, that's where we intern at. All these people made it possible for us to be here and present this project to you. So without them, we probably not have been here. And if you'd like to hear more about our project, or you want to ask us more questions, more in-depth questions, feel free to contact us. These are our details, or you can find our report. That's a report on this entire project or data collection process on our website. That's on your screen. That's a good detail. Or if you'd like to check our repo again, check it out on GitHub. Feel free to do so. With that said, that brings us to the end of our presentation, and this would be a great time to ask any questions if there is. Thank you.
Thank you.
Wow. Thank you so much for your amazing presentation. Just an absolute fantastic job. I love how you walked us through your entire project. It was just extremely well done. We have one question for you. So what advice would you have for students listening who are interested in diving into an AI research project, but they want to also learn more about open source and how that can help them? What's your advice for them?
Okay, maybe I should go first and Colin can get into fun. If you are looking to go into a research project in AI, I'd say go right ahead. I remember when we were starting out, for some weird reason, I thought research is for probably more advanced data scientists who have PhDs and loads of years of experience. But it is possible. We are an example that you as a student can start out on a research project. The important thing is to find what you're passionate about, find a problem that you're passionate about solving, and go for it. That would be my advice.
That is amazing advice. Thank you so much. And so now, thank you so much for coming on. So if you're interested in learning more about this project, don't forget to hit up the Global AI Cafe. Both of our guests will be there. And we have one final panel. We've heard from a lot of Microsoft Learn student ambassadors throughout this entire conference. So now let's actually hear from how you can grow your skills and empower. But before that, we're going to play a quick movie to get it all set up on our end.